friends, welcome to the channel. From this video we will start the subject Engineering Mathematics 2. This subject is common to all the engineering branches. This you will learn in your second semester. The subject consists of totally 5 units. We will start with the unit Matrices. So under Matrices you will learn about eigenvalues and eigenvectors, and their properties, then Cayley-Hamilton theorem, diagonalization, and then orthogonal transformation. In these topics, how to find the characteristic equation for a matrix and the problems based on the properties of eigenvalues and eigenvectors. You will get the questions in part A. And this eigenvalues and eigenvectors for a 3 by 3 matrix, that you can expect it for 8 marks, and Cayley-Hamilton theorem here also, this one also will come for 8 marks, and for the orthogonal transformation come for 16 marks. So these two together and this, or and in our choice this you will get. So what is matrix? It means, for example, consider in a bench 3 members are sitting like this, A, B, C, and in the second bench another 3 members are sitting. So while considering these two you will get a rectangular form, right? So if you express any elements in a rectangular arrangement within a bracket, that is called as matrix. So matrices means the rectangular arrangement of elements is called as a matrix. And the order of the matrix is written as m into n, where m is the number of rows and n is the number of columns. So this matrix we can write as this 2 cross 3 matrix. If the number of columns and the number of rows are equal, we can say that is a square matrix. A 3 cross 3 matrix or a 2 cross 2 matrix are called as the square matrix. You may have a question that where this matrix finds application. As an engineering student, you might have come through various system of equations. To solve the system of equations, matrices is the best way. And in for electrical students, while learning the theory of electrical circuits, matrices will help, especially in computer applications. For writing the computer application programs, matrices is only involved. Okay, so here certain matrices, what you will know, that row matrix means that will consist of only a row. Column matrix, for example, this is the row matrix, consists of a row only, right? Then column matrix consisting a column. This is a column matrix. And then unit matrix. You will have only the diagonal elements, and the diagonal elements all are 1. This is called as the unit matrix. And then singular matrix and non-singular matrix. Singular matrix means if determinant A is equal to 0, then that matrix is called as the singular matrix. If it is not 0, then that matrix is called as non-singular matrix. For a non-singular matrix only, we can find the A inverse. The inverse matrix, A inverse, can be given by the formula 1 by mod A into adjoint A. The next thing is how to find the characteristic equation of a matrix. So that is, for example, let A be a matrix. There is a formula to find this, that is determinant A minus lambda I is equal to 0, where lambda is a scalar, that is any number, I is a unit matrix. If you subtract this lambda I with the given matrix and find its determinant and equate it 0, you will get the characteristic equation. There is another method also, that is, you can assume that the equation is lambda square minus S1 lambda plus S2 equal to 0. This I will say for only 2 cross 2 matrix. For 3 cross 3 matrix, I will explain in the next video. So here S1 means sum of the diagonal elements. S2 means determinant A. If you find this value and substitute in this equation, you will get a quadratic equation. That equation is the characteristic equation of a 2 cross 2 matrix. After finding the characteristic equation, we need to find the eigenvalue and the eigenvector. Do a problem. Find the eigenvalues and eigenvectors of the matrix 4, 1, 3, 2. So first, for this, write the given thing. Let the matrix A equal to 4, 1, 3, 2. Here we need to follow 3 steps. First thing is, we need to find the characteristic equation. The second one, to find the roots for the characteristic equation. The roots of the equation will give you the eigenvalues. Then with the roots, we need to find the eigenvectors. These are the 3 steps. So I have told you the 2 methods, right, to find the characteristic equation. We will do the both. First thing is, determinant A minus lambda I is equal to 0. So for this we need to find A minus lambda I. Here the given matrix A is 4, 1, 3, 2 minus lambda into identity matrix 2 cross 2 matrix or the unit matrix is 1, 0, 0, 1, which is equal to 0. So first subtract this, you will get 4 minus lambda into 1. So you will get 4 minus lambda, 1 minus lambda into 0 is 0. So that you will get 1 only here, and 3 minus lambda into 0 is again 0, therefore we will get only 3. 2 minus lambda into 1 minus lambda, therefore it will become 2 minus lambda. So for this equation, for this matrix, if you find the determinant, that will give you the characteristic equation. Therefore 4 minus lambda (1), 3, 2 minus lambda is equal to 0. So cross multiply 4 minus lambda into 2 minus lambda, minus of, again cross multiply this, 1 into 3 equal to 0. So 4 2s are 8 minus 4 into lambda, that is 4 into minus lambda, you will get minus 4 lambda minus lambda into 2, minus 2 lambda minus lambda, that is plus lambda square minus 3 equal to 0. 8 minus 6 lambda plus lambda square minus 3 equal to 0. So if you rearrange this, you will get lambda square minus 6 lambda. 8 minus 3 is nothing but plus 5 equal to 0. So this is your required characteristic equation. This you might have checked with the another method also, that I will show you. The another way is lambda square minus S1 lambda plus S2 equal to 0. First I will write the matrix A equal to 4, 1, 3, 2. S1 is sum of the diagonal elements. Here the diagonal elements are 4 and 2. So add it. So S1 is equal to 6. And S2 is determinant A. That is 4, 1, 3, 2. Cross multiply. 4 2s are 8 minus 1 3 is 3, that is 5. Substitute these values in the equation so that you will get lambda square minus 6 lambda plus 5 is equal to 0. This is our required characteristic equation. In any one method you can find it. And the next thing is to find the eigenvalues. This is our next step. So how to find it is, the eigenvalues are nothing but the roots of the characteristic equation. So since it is a quadratic equation, you can easily solve it. We know that the 6 is the sum of the roots and the 5 is the product of the roots. So we need 5 by multiplying two things, that is 1 and 5. But when you add these two, you need to get minus 6. So what we can do? We put minus before this. So minus 1 plus minus 5, you will get this minus 6, right? Yes. So these are the roots of the eigenvalues. So substitute here this 6 lambda, we have split into minus lambda minus 5 lambda. So split it. Plus 5 equal to 0. Take lambda common, you will get lambda minus 1. Again minus 5 common, again we will get lambda minus 1 equal to 0. And lambda minus 1 into lambda minus 5 equal to 0. So if you equate these things to 0, you will get lambda equal to 1, 5, which are the necessary eigenvalues. If you want, you can do these steps, or you can simply, the roots what you are getting here, if you equate it, if you write like this, you will get the eigenvalues. But this direct thing you can use only when the coefficient of lambda square is 1, or else you need to do these steps. The next thing is to find eigenvectors. This is our third step. So for this first step, what we need to do is, need to find that A minus lambda I into x. X is the vector which is the eigenvector, equal to 0. So first we need A minus lambda I. So what is our A? Here 4, 1, 3, 2 minus lambda into 1, 0, 0, 1 into x1, x2 is equal to 0. If you have simplify it, you will get 4 minus lambda 1, 3, 2 minus lambda into x1, x2 equal to 0. So this is a required equation for finding the eigenvector. Here we need to substitute each eigenvalue to find the corresponding eigenvector. So the eigenvalues are 1 and 5, right? So first substitute lambda equal to 1 here. If you substitute, what we will get? 4 minus 1, 3. 1. Here 3. And 2 minus 1 is again 1. Into x1, x2 is equal to 0. Okay. So if you multiply it row by column, you will get 3x1 plus x2 equal to 0. Again 3x1 plus x2 equal to 0. You get both the equations are the same equations. So take the first equation that you can write as 3x1 equal to minus x2. Then bring the coefficient of x1 to the denominator of the x2 side and x2 to the denominator of the x1. So here what is the coefficient of x2? Minus 1. Bring it down. x1 divided by minus 1 equal to x2 divided by 3. Right? So if you write these elements in a matrix, you will get that is the eigenvector. That is the first eigenvector x1 corresponding to lambda 1. The answer is minus 1, 3. Then if you substitute lambda equal to 5. Substitute here 4 minus 5 is minus 1, 1. 3, 2 minus 5 is minus 3 into x1, x2 is equal to 0. So row by column, multiply it. You will get minus x1 plus x2 equal to 0. 3x1 minus 3x2 equal to 0. Again, these two equations are again the similar equations. So let me take the first equation alone for lambda equal to plus 5. Then you will get minus x1 plus x2 equal to 0. This we can write as x2 equal to x1 or x1 equal to x2. Right? So here also bring the coefficients to the other side. So for x1, what is the coefficient of x2? 1. Bring it down. Similarly for x2, what is the coefficient of x1 here? That is also 1. So the eigenvector x2 for the eigenvalue lambda equal to 5 is 1, 1. So we can write the answer as, for the given matrix A equal to 4, 1, 3, 2, the characteristic equation is lambda square minus 6 lambda plus 5 is equal to 0. And the eigenvalues are 1, 5. And the eigenvectors, corresponding eigenvectors are what we got 1 pi minus 3, minus 1, 3, comma 1, 1, right? So don't forget to write the result or the answer like this, because this also will carry mark. So don't lose any mark. So in this video we have learnt about how to find the eigenvector and eigenvalues for a 2 by 2 matrix. The next video I will tell you how to find the eigenvalue and eigenvector for a 3 by 3 matrix. That 3 by 3 matrix is very important. That will definitely come for 8 mark question. So we'll see you on the next video. Thank you friends.
இந்த சேனல் உங்களுக்கு பிடிச்சிருந்தா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க.